Hello, I'm going to demonstrate today how Iguazio and NetApp are bringing data science to life. First, the challenge. Today, in research environment, we usually take some small data, we train it, we explore it and visualize it, and finally, at a certain point, we need to productize our pipeline. That involves many different tasks, like ingesting data from ETLs, from streams, from APIs, running contextualization and data analytics across all of this data at scale, running training in an automated fashion using multiple algorithms, and finally serving our models and incorporating it into real-time applications that need to serve data 24/7. This is a very tedious and long task that involves many different steps, such as packaging our code, scaling out our workloads for data and training, tuning for performance, adding instrumentation, logging, monitoring, versioning, security, etc., and finally automating the entire process so it can become repetitive. That process can take many, many months. We'll see how using NetApp and Iguazio technology we can automate the entire process and make it the life simple, as well as allow you to build applications and drive them into production, into real value, much faster and quicker to market. So the solution comprises of three different layers. The first layer is the data. This is where NetApp has one of the best technologies, shared file system, distributed and federated globally. There's also Iguazio real-time databases that can be part of that layer. On top of it, you have an automated workflow which comprises of serverless functions. Serverless functions that some of them run in real time, some of them run in batch, and they deliver all those different steps in the pipeline, ingesting data from a variety of sources, offline or online, preparing the data in scale, training the data using multiple algorithms, validating the data that was trained and those models that were trained, and finally deploying functions that are serving requests in real time, running against real-time data, real-time features, and also collecting telemetry that will feed back into our pipeline. So let's see a demo of how we build this entire pipeline in a few simple steps. This is Iguazio self-service data science portal where we can manage data, run analytics and machine learning tasks, and control many services which are open source and managed through our service. You can see the list of services here, and you can create new services from a catalog or assign them to various users. But let's go back and see our notebook and create a full-blown pipeline. The first step of every pipeline is to collect data and analyze it. So we'll see how we can just open a notebook and create some function which will be used to analyze or generate or ingest data. Once it's ready, we can further automate it and put it part of a pipeline. This is a function that generates fake iris data just for sake of simulation. We can write the function here. We can add all sorts of decorations which will later on tell us how to convert this into a real serverless function. For example, package dependencies, resources, etc., triggers, and more. So we create this function. We also want to create a project. This project will allow us to package all the artifacts, data, information, tracking under one project context. So we'll create this project called SK project. And now we'll just run our function. This function is wrapped with all the tracking for experiments, data, etc. We use this run local command, which just runs our function locally and records all the data. This way we can iterate, we can bring data, ingest, prepare, etc. What we want to do next is essentially analyze the data. We don't want to work too hard, so let's just pull a library function called describe, which knows how to take our data, analyze it, and run it on a separate container. This container could involve GPUs, could scale out. All the packages are pre-installed and optimized in that container. We don't need to work too hard. So we pull this function describe from a marketplace. We add it to our project, and we just run it. We also apply a mount, which will connect our function to NFS using the Trident driver. Just run it with a set of parameters, and the input data set is the one that we just generated. So we can run this describe analytics function and it will generate a bunch of plots. Those plots will come back into our system and we could just go and view all those very advanced plots that analyze our data, figure out the best features, etc. We don't need to work again too hard on those aspects. We can also visualize all this information in MLrun UI. We just open the UI. We can see this distract function with all the metadata that it gathered. We can see all those artifacts we just mentioned and others. We can look at the logs of that function. We can also look at our iris generator function, the one we ran before in the notebook. It also recorded everything, including the data and the metadata and statistics, into the artifact database. Going back into our project, now we want to create a full-blown pipeline. The pipeline involves ingesting the data using the function we just written, analyzing it using the describe function, running classification using AutoML. Once we do classification, we want to run validation. Once we do this validation, we want to deploy the model in a serverless serving layer. And once it's deployed as a serverless function, real-time serverless function, we want to test it and verify that this serverless function really works and the latency is adequate. So we pull functions from the marketplace for classification, testing, serving, and testing of the serving model. And we just form them in a pipeline. We use the kubeflow pipeline language, description language, for creating a pipeline. This function starts with initializing our functions with various resources like mounting them on a file system, providing a location for the model serving functions to write all their inference streams into that location so we can later on monitor our functions, model serving function behavior. And we can write this graph, this DSL graph, which shows how to connect the functions and data to each other. So we start with building our new generator function. Once it's built, we run it. And we take the output of the build. Once we run the ingestion, we run the analytics function, which analyzes the output of the generation of the ingestion function. Once that's done, we also want to run training. The training takes the data from the ingestion function, and it can use AutoML to run various experiments on the same data in parallel. So we can run all those things in parallel and save time. The training also feed into a testing layer. The testing layer would take the model from the training and as well as test data and verify our model and tell us its accuracy with another data set. Once all those things are ready, we want to deploy a model serving function, which is potentially going to be used for serving our model. So we run a deployment of that function, taking the model from the training step. Once the function is deployed, we want to verify that it really works. So we use a live tester function, which is essentially ingesting data through RESTful APIs into our model serving function, measuring the latency, measuring the performance, and eventually telling us it's all great. Once the pipeline is ready, we just run it. We can just go and run with various algorithms. We also can use this decoration to create versioning of our artifacts. Every artifact will go to a different location. Later on, we can also monitor the progress of our pipeline. But let's look at kubeflow pipeline, which is a tool for monitoring all those pipelines. You could say I can have various runs and compare them. Just digging into the latest run, we can see all those steps that I just mentioned. First, getting the data. Here is a snapshot of our data. Running training. Here is the results of the training, our C-curves and other widgets. We're also analyzing in parallel the data set. And we can see the same widget we've seen before for various feature analysis capabilities. We run testing on the model with a different data set just to verify it on a larger scale. Again, all the results of the testing. And we also run deployment. We took our model and created a function, a serverless, real-time serverless function out of that. We'll see that function in a minute. And we can see the logs. We can see that it actually generated an endpoint, a RESTful endpoint that is serving our model. And we ran our testing, which takes the model, takes the test data, and verify our model serving function is really acting and performing according to our needs. When we ran our pipeline, everything was recorded in the experiment and artifact database. We can just go back and see all those different steps. Let's jump for a second into the training. You can see we did AutoML. We ran multiple algorithms. Everything is recorded, and we can see that the system automatically selected the best model with the best accuracy with logistic regression in that case. Again, we can see all the artifacts with all their details. Here we can see the logs, we can see that for every step. We can also go back to the project and look at the artifacts from a different perspective, or the code that was used for every run. For example, going into this data set in the artifact repository, we can see what was generating that, which were the sources used for that generation. We can also look at the data and even the metadata and the statistics of that artifact. Now, once we have this, we want to look at the actual function. So let's see the real-time model serving function. We have the version 1, which is the previous one. It's hooked out now into the actual serving. And we have version 2, the one that we just generated. We want to create a canary deployment that some of the traffic will go to V2 and some to V1. We go into an API gateway, and we see this API gateway right now is connected only to our version 1. So let's change that. You see only V1 is connected. We're going to add the canary, connecting that into our V2 and giving our V2 potentially, let's say 65% will go into our V2, 35 will stay on the old one. Let's just save this. And now we're serving the new model. 30% of the traffic will go to the new model. 65 will go to the new model and 35 will stay with the old one. We can also monitor all the activity using two different tools. One, we can have real-time monitoring of all of our functions and all the resources, CPUs, GPUs, latencies, performance, numbers of invocation using Grafana. Everything is ready with telemetry. And another thing that I mentioned is all the results of the serving engine are feeding back into a stream on the Iguazio real-time data layer. So we can just open up a notebook and run a simple command to see all the invocations or functions along with the data that was provided, the feature that were provided, the results, the estimates, and this information can further be used to understand the behavior of our model, detect a drift, create ensembles, do A/B testing and evaluate the A/B testing performance, and also just feed this data back into the system for retraining our model. For more information, contact NetApp or Iguazio and we'll help you bring data science to life.